Here is a circle, it knows how to get around. It has a radius from center to rim, and its diameter's a line that goes from side to side while passing through the center. Now isn't that simple? Pi r squared sounds like area to me. When I need a circumference, I'll just use pi d. Pi r squared sounds like area to me. When I need a circumference, I'll just use pi d. Here is a circle, it knows how to get around. It has a radius from center to rim, and its diameter's a line that goes from side to side while passing through the center. Now isn't that simple? Pi r squared sounds like area to me. When I need a circumference, I'll just use pi d. Pi r squared sounds like area to me. When I need a circumference, I'll just use pi d.
Speaking of pi, what an interesting number pi is. Pi is a number which goes on forever after the decimal point without repeating. Here's pi to 31 digits, and you might want to write this down because I'll be referring to it later. 3.14159 26535 89793 23846 26433 83279. If you memorize the following verse, you'll know pi to 13 digits.
See, I have a rhyme assisting my feeble brain, its tasks oft times resisting.
Just count the letters in each word. By the way, oft times is spelled OFT''TIMES, 8 letters. You never know, you may be on Jeopardy someday when this could come in handy. In ancient times, some of the estimates for pi included 3, 25 over 8, 256 over 81, 22 over 7, and the square root of 10. Here's one which is accurate to 6 decimal places. Write down the digits 113355. Now turn this into a division question at the halfway point. That is, 113 divided into 355. On your calculator, if you enter 355 and divide by 113, you get 3.1415929. That's incredible. Here are some amazing curiosities about pi. 22 over 7 and 355 divided by 113 are the best approximations to pi using fractions of 2 and 3 digits. The 7th, 22nd, 113th, and 355th digits of pi are all 2. There is also a symmetry around the 22nd digit. Look at the sequence from digit 20 to 24. 46264. In addition, 462 and 264 are both multiples of 22. The sequence from digit 14 to digit 31 is also interesting. 79, 32, 38, 46, 26, 43, 38, 32, 79. There is symmetry about the 22nd digit again, with the 79 at the beginning and the end. 79, by the way, is the 22nd prime number. 79 is also the sum of the proper divisors of 365, which is the number in the year's circle of days. What a mystical number this pi is. One final thought. The infinite series 1 minus 1/3 plus 1/5 minus 1/7 plus 1/9 and so on is 1/4 of pi. It would be a fairly simple computer program that would set up a loop to add, say, the first 100,000 terms of this series together. The result could be multiplied by 4, and that end result could be compared to the value of pi given earlier. Don't you just love numbers? I'd like to sing you a song about a lady named Christina who liked to play Lotto 649. Week after week after week, she spent $1 and bought one ticket. Never won a penny. One week, she was doing some cleaning in her attic, and she came across a lamp, much like Aladdin's lamp. When she polished that lamp, her own personal genie appeared, granting her one wish. Think of the possibilities. Anyway, being the sporting type that she was, she wished for next Sunday's paper in advance, and this is her story.
I'll grant you one wish, said the genie to Christina. Without hesitation, she gave her reply. Next Monday's paper, today, if you would please. The genie produced it, and soon he knew why. 3, 7, 9, 10, 14, 27 were there on page 1 for Christina to see. With over 5 million at stake for the winner, she'd have it made in the next lottery. She sped to the store where she always played her numbers, put down her dollar and filled in her card. Although she had never collected one penny, this time the winning would not be too hard. 'Cause 3, 7, 9, 10, 14, 27 were there on page 1 for Christina to see. With over 5 million at stake for the winner, she'd have it made in the next lottery. Well, back to her car and still clutching that paper, the future was printed as it had to be. She glanced at page 2 and her hands left the wheel, 'cause there in bold print her obituary. Oh no! 3, 7, 9, 10, 14, 27. Now she partakes of the angelic cup. No one has need of 5 million in heaven. She would have won, but her number came up.
Everybody got those numbers now? Ah yes, the sad story of Christina and Lotto 649. Everybody got those numbers out there? In a lottery like Lotto 649, from the set of natural numbers 1 through 49, you pick any 6 for your ticket. In your math classes at some point you might study why the total number of possibilities is just under 14 million. There have been times when the prize money for Lotto 649 has been 19 million, so I want to share a little plan with you. You wait till a week when the prize money is 19 million, you go to the bank and ask to borrow $14 million just for a few days, and then you go into the lottery office and you say, "I'll have one of every possible ticket, please." So you know when the draw takes place on Saturday night, you have the winning ticket. You then collect the $19 million, you repay the bank $14 million, and you're $5 million ahead. Now, I would be retired and living on a tropical island somewhere, except there's one tiny flaw in this plan. Do you know what that flaw is? Hopefully you figured out that if one other person wins on that particular draw, you've got big money problems. Because now you have to split the 19 million. That gives you 9.5 million each, but you owe the bank 14 million. One final thought. It would be a great algebra assignment to imagine that you did have one of every possible ticket for Lotto 649, and then to work backwards to figure out what would your total winnings be. Because not only would you have the first place prize for matching all 6 numbers, but you would have all the secondary prizes as well. An interesting problem. This is an algebraic problem which will allow you to determine someone's birthday. It will seem almost magical. Try it. Step 1. Write down your birthday month number. January is 1, February is 2, and so on. Step 2. Multiply by 5. Step 3. Add 6. Step 4. Multiply by 4. Step 5. Add 9. Step 6, multiply by 5. Step 7, add the date of the month. So if you were born on the 17th, you add 17. When you try this on someone else, you stop here. To get the birthday, you need to subtract 165 from the answer you get in step 7. When you do, suppose the result is 1023. The first 2 digits represent month 10, October. The last 2 digits represent the date of the month. So the birthday would be October 23rd. If the result happened to be 709, the month is 7 and the day is 9, so the birthday is July 9th. The neat thing is that you don't tell the other person about subtracting the 165, so it's not obvious why this works. Now for the question you are certainly asking, why does this work? Well, folks, it's elementary algebra. Let's let the month be M. Sounds like a great algebraic beginning, eh? Multiply by 5, and we have, that's right, 5M. Add 6, so now we have not 11M, it's 5M plus 6. Multiply by 4 to get 20M plus 24. Add 9, and now we have 20M plus 33. Multiply by 5, and that takes us to 100M plus 165. Let D be the date of the month, so when we add the date of the month, we end up with the expression 100M plus 165 plus D. Finally, if we subtract the 165, the result is 100M plus D. That 100M is what moves the month number over into the hundreds column. Pretty neat, eh? You can really impress people if you can subtract the 165 in your head and blurt out the birthday. And you thought you'd never use algebra for anything useful. I rushed to the bank, quite pressed for time. I filled out the form and got in line. I pushed ahead, the teller frowned at me. "We're very busy, sir, now can't you see?" Then I said, "Please, what are you telling me?" She said, "Please wait, in the y equals mx plus b. I hope you can cope. M represents slope, and you'd be correct to think that b is the y-intercept. They're both parts of a line, and let me remind you that you're in one. I grabbed up my cash and ran again. The station was close, I heard the train. The ticket master shouted out at me, "We're very busy, sir, now can't you see?" Then I said, "Please, what are you telling me?" He said, "Please wait in the y equals mx+b. I hope you can cope." M represents slope, and you'd be correct to think that B is the y-intercept. They're both parts of a line, and let me remind you that you're in one. I traveled by train, it took me hours. Then I got in line to buy some flowers. The long-stemmed roses were for Laura Lee, but I found out she hadn't waited for me. She had made plans with Ralph and Freddie V. She said, "Please get in the y equals mx+b. I hope you can cope." M represents slope, and you'd be correct to think that B is the y-intercept. They're both parts of a line, and let me remind you that you're in one. A line stretches on, it has no end. But this song is through, it's done, my friend. Is there a moral to this sad, dark tale? Each story has one lest the author fail. Yes, there's a message, it's so plain to see. You'd better be first in the y equals mx+b. Be first in line.
Do you believe this, Eve? We're here on the class music trip, and we're about to hear the famous Italian opera singer, the tenor Enrico Rigatoni, live at the Sky Dome, the acoustical palace that it is. What a moment!
A famous tenor, you say?
Yes, Eve. The Italian opera company was going to trade him for 2 fivers, but in the end, they decided a tenor was better.
Ooh, that's pretty rank, Adam.
I know, Eve, but what can you expect? I heard it in math class. Speaking of math, Eve, I've been having some trouble with that new stuff. You know, trigonometry.
That's trigonometry, Adam, and I don't know what you find difficult about it.
I can't tell a cosine from a coefficient, Eve, and I don't know a theta from a gamma ray. I'm in big trouble.
Well, just for today, take your mind off math and enjoy the opera.
Is that an oxymoron, Eve? Enjoy the opera? Just kidding, Eve. Which opera are we seeing anyway?
It's called SOHCAHTOA.
SOHCAHTOA? How do you spell that?
SOHCAHTOA.
And what does it mean?
I think it's Italian for I finally see the light.
Ooh, look, Eve! Here comes Enrico Rigatoni, walking on stage right now. This is gonna be great!
I used to have such trouble with trigonometry. The alphas, betas, thetas were also Greek to me. Dear sine, cosine, and tangent, I never got to know ya, till someone stood right up abruptly shouting SOHCAHTOA. Sine is opposite over hypotenuse, cosine's adjacent over hypotenuse. Now I'm feeling quite complacent, 'cause I know that tangent is opposite over adjacent. I'm quite complacent over adjacent, and now I know. I travel triggy roadways reading signs along the way. Do I know all the ratios? Of course I do, I say. I'm off on this new tangent, come here and let me show ya. And all because I heard that lovely word SOHCAHTOA. Sine is opposite over hypotenuse, cosine's adjacent over hypotenuse. Now I'm feeling quite complacent, 'cause I know that tangent is opposite over adjacent. I'm quite complacent over adjacent. Now I know. SOHCAHTOA.
Wow, that was truly enlightening.
Yes, it certainly was, Eve. And I just have one thing to say. SOHCAHTOA. I finally see the light. Oh, by the way, Eve, I know you packed a lunch for us. What's in it?
Rigatoni on a bun, Adam.
Okay, pass the rigatoni, Eve.
Here's a great problem-solving activity. You need 10 cards, ace through 10, and we'll think of the ace counting as a 1. You can use ordinary pieces of paper numbered 1 to 10 if you want. What you need to do is to arrange the cards in order to accomplish the following. Move the top card to the bottom of the deck. Turn over the new top card, which must be the 1 or the ace. Set that card aside. Now move the top 2 cards, one at a time, to the bottom of the deck. Once you have done this, turn over the new top card, which must be the 2. Set the 2 aside. Now move the top 3 cards, one at a time, to the bottom of the deck. Once you have done this, turn over the new top card, which must be the 3. Got the idea? The pattern is to continue until all cards have been set aside. Once again, your task is to figure out how you must order the cards at the start so this can all be done. Some people can figure it out in under 10 minutes, and some people take the better part of an hour to get it. It doesn't really matter how long it takes you. What is important is that you stick with it until you solve it. Once you have solved it, you might want to compare your method of arriving at the solution with the method other people used. This usually produces some very interesting dialogue. Let's talk about powers of 2. Round up one of those old calculators that doesn't know Bedmas and try this. 2 times equals. You should get 4, which is 2 squared. If you hit equals again, you get 8, which is 2 cubed, and if you hit equals again, you get 16, 2 to the 4th. Got the idea? Powers of 2, just by hitting that equal sign. Let's relate it to something tangible. Let's take a chessboard. 8 squares by 8 squares, 64 squares in total. Suppose on the first square we were to put 2 pennies. On the second square, 4 pennies, then 8 pennies, 16 pennies, and so on. Could we fill up the whole chessboard with pennies in this manner if we got everybody in the school to bring in their spare change? Well, let's go back to the calculator. 2 times equals equals equals. Keep pressing that equal sign to get increasing powers of 2 and see if you can get all the way to 64. Or does your calculator give up on you? Now try this. Take a scientific calculator and enter 2 y to the x 64. You should get 1.8447 and then a space and then a 19. That 19 after the space means move the decimal point 19 places to the right. If you write that number on the board and actually move the decimal point over, you've got a number of pennies for the 64th square. Now divide that by 100, that gives you a number of dollars for the 64th square. That doesn't include the 63rd square, the 62nd, all the way back to the first square. Now, everybody in the school brings in all their pennies, under the sofa cushions, in the piggy banks, the coins, in the wallets, in the change purses. Do we have enough money to fill up the board? It's a lot of cash. The Quadratic High School Marching Band.
Negative B, plus or minus the square root of b squared minus 4ac all over 2a negative b, plus or minus the square root of b squared minus 4ac all over 2a negative b, plus or minus the square root of b squared minus 4ac all over 2a negative b, plus or minus the square root of b squared minus 4ac all over 2a.
Some thoughts on square root. The number 9 is a perfect square. It has an integer as its square root. What is that integer? 3, right? 3 times 3 equals 9. Interestingly enough, 9 has another square root, and perhaps you already know what it is. What other number times itself equals 9? Often there are students who do not believe a number like 9 has another square root. Some of these students insist there is no other possibility. Well, normally I would suggest to people that they should be positive thinkers, but in this case, it would help to be a negative thinker. Have you figured out what the other square root of 9 is? If you take the square root of the square root of a number, what root do you get? What if you enter a number on your calculator and press the square root button repeatedly? Do you always get the same result if you continue long enough? Does this work even if you start with the largest number you can possibly enter on your calculator display? What if you started with a number and took the cube root of the cube root of the cube root of the cube root and so on? Would you get the same result? Great questions. Time to experiment with your calculator. A long, long time ago, I can still remember when those numbers used to make me cry. But I knew if I had my chance, I could make those figures dance, and in math class I'd be happy for a while. But studying just made me quiver, and each math fact would send a shiver. Bad news on my math test. It sent me on a new quest. I still recall with greatest pride the day my mind was opened wide. Math's importance got inside the day I really tried. And now I'm saying, why don't you learn about pi? Get ecstatic about quadratics and let calculus fly. Take a swig of trig and you will be on a high, saying this'll be the day that I try. There are always new challenges and new math frontiers to explore, so I think there should be a sequel to this tape. If I can just think of a good title, let's see. Math, Music, and Mayhem, Roman numerals 2. No. Math, Music, and Mayhem, Beyond Pi. No, wait a minute, I've got it. Math, Music, and Mayhem meet Rocky 14 for the ultimate math heavyweight championship of the world. See you next time.